On December 5th, 2013, a powerful storm surge made its way down the Humber Estuary. It resulted in record-breaking water levels and overtopped 40 kilometres of its flood defences. 1,170 properties were flooded around the estuary that night, and I'm on the outskirts of the village of South Ferriby where many of those properties were. 10 years on, the area is still responding to that storm surge. They are strengthening their defences, they are building their resilience, and they are preparing for a future where events like that will be 1 metre higher due to sea level rise in 100 years. So join me, Dr. Chris Skinner, in this episode of Floodology as I explore what happened on that night, what has happened since, and what might happen in the future. After battering the northeastern coastlines of the UK, the storm surge arrived at the Humber Estuary. Its first target was Spurn Point. This feature has a long history of flux, switching from a spit to a chain of islands, shifting sandbanks, and everything in between. However, over the last 2 centuries, it has been strongly defended against the tides, separating the water in the estuary from the water in the sea. Over its history, Spurn Point has been used for many things, including hosting a town, hunting for U-boats, guiding shipping through the estuary, and for launching lifeboats from. Without a military function post-World War II, it has been largely left to nature and has become a wildlife reserve. As the storm surge arrived, the force of the water punched through the human-made sandbank and momentarily reunited the waters of the estuary and the sea in this area and created a new beach. Aerial laser scanning data of the area from before and after the event shows the scale of the damage that was done and this new breach through Spurn Point. Our next stop are the ports of Immingham and Grimsby. 10% of the UK's seaborne trade passes through Immingham, and 27% of the UK's oil refining capacity resides here. The port at Grimsby handles 500,000 new cars every year. Together with the other Humber ports in Hull and Gull, a quarter of the UK's imports pass through here. At 7:15 in the evening, a peak water level of 5.22 metres was recorded. This was way above the previous record of 4.8 metres that was recorded in 1983, and easily the highest water level recorded since the records began in 1963. This was over 1.5 metres higher than the peak tide estimated for that evening. Seawater flooded into both docks at Immingham and Grimsby, closing them immediately and causing disruption for weeks. Shortly after, and at astonishing speed, the storm surge arrived at the city of Hull. This is the largest urban centre around the Humber Estuary and is home to 300,000 people. Hull is a city that is built on floods and is extensively defended against that risk that comes from the sea. At the heart of this defensive wall is Hull's tidal barrier. Opened in 1980, it offers a 0.5% annual exceedance probability level of protection. This means that there's just 0.5% chance that the water level in the sea will be high enough to go over the top of it every year. To put it another way, given enough time, such events would happen on average once every 200 years, so we'd expect them to be pretty rare. On December 5th, that barrier closed and provided a physical barrier against the water from the sea travelling inland where land and flood defences are lower. That line of defences with the flood barrier at the heart of it is estimated to have stopped the floodwater reaching 19,000 properties in the city and the land beyond. But it was close because water levels here reached a record 5.8 metres and came very close to overtopping the barrier. However, 300 properties did flood in Hull as water came over the defences in other areas of the city and spread far inland. Here on the south bank, in the village of South Ferriby, residents describe the sound of water rushing over these floodwalls as sounding like a waterfall. Water spilled out of the estuary, over these floodwalls, over the A1077 and into people's houses and the Cemex factory in the background. And water was not the only problem people had to deal with. It brought with it silt and mud that plastered the floors and the walls of their houses. And that silt and the saltiness of the brackish water in the estuary brought additional problems to the Cemex factory. It corroded all of their electrics, requiring the factory to be completely refitted, something which took over a year to do. Our last stop is Alkborough Flats, right at the point where the Humber Estuary meets the rivers of the Ouse and the Trent. This large area is a mix of farmland and an area which has been deliberately allowed to flood during high tides to create a new wetland habitat. It makes an ideal habitat for the many migratory birds that visit this area. During really high water levels, this entire area is deliberately allowed to flood. The idea is that some of that floodwater is stored on this site, and then there's less water around to flood people's houses and properties. On December 5th, 2013, it did exactly what it was supposed to do, and this entire area filled with water. I used my model of the Humber to estimate what impact that flood storage had on flooding around the estuary. I created a scenario where this site wasn't allowed to flood during the storm surge. And when I did that, the volume of water that flooded elsewhere in the estuary increased by 10%, including at Hull and in South Ferriby. By allowing this site to flood, other areas were spared. Autumns and winter in the UK can be very stormy, and that's because we're right in the path of the jet stream. It's a windy area high up in the atmosphere where cold polar air from the north meets warm tropical air from the south and exchanges. The jet stream is at its strongest when the temperature difference between these two air masses is the greatest, and that's at the end of the year. With all this energy, the jet stream can become unbalanced and create areas of low pressure. These have the potential to develop into storms and bring a lot of rain and wind, and the UK is right in the path. The weight of the atmosphere is constantly pushing down on the world's oceans. When air pressure is lower, some of that weight is lifted and the ocean rebounds, creating a bulge. Strong winds that circle the storm are also capable of sweeping that water to one side, further building that bulge. This is a storm surge, a localized area of raised water level. When these storms track in a certain way over the north of Scotland and into the North Sea, surges can impact the east coast of the UK and many areas of Northern Europe. But surges travel and they move, so they'll only impact an area for a certain window of time. However, they only usually pose a risk of flooding when they coincide with a high tide, and that combination of high water levels is enough to overtop localised defences. This is exactly what happened on December 5th, 2013, when a storm surge of over 1.5 metres coincided with one of the highest tides of the year. And things are not going to get easier. As a species, we are polluting our atmosphere with gases that insulate the planet and raise global average temperatures. These increased temperatures are melting water in ice sheets on land and stored in glaciers, and that water is going into the world's oceans. The world's oceans are also warming up, and warmer water expands and takes up more space. The combination of this means sea levels are increasing around the world at an accelerating rate. The UK Climate Projections of 2018, or UKCP 18, estimates that in the Humber, sea level could rise by between 1 and 1.3 metres by the year 2100. That's almost the same as the extra water level of the 2013 storm surge, but all the time. This means that a similar event to the December 5th, 2013 storm surge happening in the year 2100 would be over a metre higher. That would easily be enough to overtop most of the Humber's defences in 2013, including Hull's tidal barrier. But the Humber is not standing still. It is taking action to make itself more resilient and to make itself safer against future flooding. There has already been many changes around the estuary. In South Ferriby, England's Environment Agency has constructed new flood defences to protect 150 properties, including the 129 that were flooded in 2013. This includes a secondary and stronger line of flood banks and a new floodgate across the A1077. The Hessel foreshore defences are protecting 4,000 properties from flooding. Part of those defences uses this glass wall to maintain the area's important connection to the water. And in Hull, the Hull Frontages project is reducing the flood risk to an incredible 113,000 properties. They include these glass walls in the heart of the city and around Hull's tidal barrier. To meet the challenges of the next 100 years and beyond, more will need to be done around the Humber, including either strengthening or replacing Hull's iconic tidal barrier. But it is a challenge that the people of this area are prepared to meet head on, ensuring the prosperity of this unique and beautiful region for generations to come. Thank you for watching. If you've enjoyed this video, please do support my channel by giving this video a like and subscribing to the channel. But for now, stay dry out there.